Hello, math students. Let's continue today, still working with solving systems by substitution. Now that we've done some of these problems, maybe these steps from yesterday make a little bit more sense. And I said that yesterday step one was done for you. Today, that's what you're going to have to add. You're going to have to do some work to get one of the variables by itself. Then we take that, whatever it is, x equals something or y equals something, and we substitute it into the other equation. That's very important. It has to go into the other equation, not back into the equation that you were just working with. When you do that, you'll be able to figure out one of the variables, either the x or the y, and then you have to go back into one of the equations and find the other variable so we can get our ordered pair. So yesterday, so nice. Every time I gave you a variable already by itself, but if I don't have a variable isolated all by itself, you're going to have to do that. But you're lucky. You know how to do that. Think about when we were graphing lines and we had to get the y by itself. That's what we're doing here. It's not always going to be solving for y, but you know how to get a variable by itself. You know how to rearrange things in an equation. So if I have these two equations, I'm not even going to solve this problem. I just want to know if these are my two equations, I have them side by side instead of stacked one on top of the other, which variable would I want to solve for? Keep in mind, you can pick any one of them. It doesn't matter. However, whatever coefficient is in front of the variable that you choose, you're going to end up dividing by that, right? So in my first equation, if I chose to get this x by itself, I would end up dividing by 2, which isn't horrible, except that doesn't divide nicely by 2. I'd have a fraction left over. Or if I chose this y, I'd be dividing by this 3 and the 2 and the 8. Neither one of those divide nicely by 3. I'm skipping over the x in the second equation for a reason. If I wanted to get this y by itself, I would end up dividing by -4, which would give me fractions. The one that I'm going to choose is clearly, the only one that I didn't talk about yet, the x, because I don't have to divide by anything. Sure, I could put a 1 in front of it, but that doesn't do anything when I divide anyway. If I wanted to get the x by itself, all I would have to do is just move that 4y. So to get rid of subtracting 4y, I would add 4y. So I'd have that x equals 4y minus 1. 1 minus 4y is just fine. It's just that we're used to writing the variable thing first. That's what the x would be. And again, I'm not going to solve this, but if I were, that stuff would have to go in place of the x. So look at these two problems now. Which variable makes the most sense? Which one doesn't require any dividing? Because if I can avoid dividing, that's what I'm going to do. So in this problem, that's the one that would be the easiest, that y. So all I would have to do is just subtract the 2x. And I would have that y equals -2x plus 4. Basically, that's slope-intercept form. That is my y. It would have to go over here in place of the y. So now I'm going to solve using substitution. In this problem, in these two equations, I truly could use 3 of the 4 options and have no issues at all. The only one that I wouldn't choose is this x right here, because I would end up dividing by 3 to get the x all by itself, and then I'd end up with a fraction in front of the y. I'm going to pick, in this first equation, I'm going to pick the x. This is what I am going to get by itself. So I would subtract 1y. I'll have x equals, I'm going to say -y minus 3, or plus a -3. You can put a 1 there if you want to. But that is my x. That goes instead of the x. So I would have 3, and then instead of the x, I would put in that -1y plus a -3. And the rest of this equation was plus y equals 3. So when I distribute, I'll have -3y plus -9 plus 1y equals 3. So I'm going to combine my y's. I'm also going to add this 9 at the same time. So I would have negative 3y plus 1y is going to be negative 2y equals 12. So y equals negative 6. Once I know what the y is, I need to go back and find the x, and the easiest place is where it says x equals. So I would have x equals negative 1 times negative 6 plus negative 3. So this is just going to be 6 plus negative 3. So x equals 3. My ordered pair would be 3, negative 6. In this problem, I could pick either the x from the first equation or the y from the second equation. This time I'm going to go with the y, I guess, just because I went with x in the first one. So we're going to get this y by itself. How do I get rid of adding 3x? Well, I would subtract 3x. So I get that y equals 0 minus 3x is just negative 3x. That's my y. That goes instead of the y. So I would have x minus 2 times that negative 3x equals 0. So that's x plus 6x equals 0. So 7x equals 0. X is 0. Once I know that, I want to go to where it says y equals. This one's a really nice problem because it's going to say y equals negative 3 times, x was 0. So x was 0 and y was 0. So this ordered pair is just going to be 0, 0. In these two equations, I have a definite preference this time. Sometimes I'm like, we could pick this one, we could pick this one. Excuse me. I would absolutely pick this x right here because that's the only one that I don't have to divide with. So I would subtract 5y. X equals negative 5y plus 7. Remember, we like the y part first, or the variable part first. That's my x. It's going to go right there. So I'll have 2, and then instead of the x, I'll put in this stuff. So now solving, I've got negative 10y plus 14 plus 5y. So let's move the 14 and let's combine our x's. So I'll get a negative 5y equals negative 10. So the y is 2. Still need the x. Go back to where it says x equals. X equals negative 5 times 2 plus 7. So my ordered pair would be negative 3, 2. In this problem, some people might say, well, either x is fine. And truly it is, but in the first equation, that negative is really a negative 1. I would have to divide by negative 1 there. So instead of doing that, I am going to pick this x and say I'm going to get rid of the 6y by subtracting. X equals negative 6y plus 14. That is the y. So I will have negative 1x plus 3, and then don't forget your parentheses. Here's the y. I drew my arrow wrong and messed up. I'm sorry. This is the x. It goes there. So I'll have that negative 1 outside of parentheses. I guess the parentheses should probably be the I'm substituting here. So negative 6y plus 14 plus 3y equals 4. Positive 6y minus 14. Let's add the 14. And we'll combine our y's to get 9y equals 18. So y is 2. And again, if I know what the y is, I will go where it says x equals, so negative 6 times 2. So that's going to be a negative 12 plus 14, and x will be 2. So this ordered pair is just 2, 2. Last problem. I would pick either the x or the y in the second equation. So let's pick the y. We just did a couple with x's. So let's subtract this 1x. That's what the y is. That goes in place of the y. So I'll have 2x plus 2, and then instead of the y, I'm going to put in negative 1x minus 2 equals 8. 2x plus negative 2x minus 4 equals 8. Okay, now here's an issue. Those are going to cancel out. I get negative 4 equals 8, and then I would say, wait a minute. Negative 4 does not equal 8. That is a no solution. If you get down to where all the variables go away and you have a statement that is not true, that's a no solution. I'm hoping that you're guessing right now what's going to happen on this problem. So here, let's start with getting this x by itself. Subtract 4y. X equals negative 4y plus 7. That is my x. So I would have 2, and then instead of the x, put this stuff in its place. Switching. Oh no, that's the right color. Plus 8y equals 14. Negative 8y plus 14 plus 8y equals 14. And again, these y's are going to cancel each other out. So I end up with 14 equals 14. If I had graphed this, you would find that these two are exactly the same lines. Because this would be, typically you would look at this and you'd say, oh, it's any real number. This is all points on the line. So today's worksheet, actually I changed these numbers. I made this into a worksheet. It's from the book Problems, but this is actually 10 through 14, and then 18 and 21, I believe, are the problem numbers. But it's on the worksheet. It's linked in Schoology. The answer key is in Schoology, and there will be a learning check when you're done. Let me know if you need any help.